quick look here at how to solve inequalities, but using the GDC rather than any algebraic techniques. Let's take this first example of solving 5 over 2x minus 1 is less than 3. What we'll do is we'll go onto our GDC and we're going to graph the left-hand side, 5 over 2x minus 1, and then we'll graph the right-hand side, y equals 3, and we'll then look at the intersection points and basically try and see when is this part less than, i.e. lower than, this part. So let's type all of that in here first of all. And you can see it's a similar technique to what you would use if you were trying to solve equations using a graphical technique, using your GDC. So we'll put in that fraction. So it was 5 over 2x minus 1. So the shortcut Control, divide, and then I can type in 5 over 2x minus 1. So that's my first part graphed. And then press Tab to enter a new graph, and we're going to now do y is equal to 3. And as I said before, you're trying to basically figure out when is 5 over 2x minus 1, when is that less than 3? When is that less than y equals 3? So basically, when is the blue curve lower on the page, so below the red curve? And you can see it's below it from here onwards. If I go from wherever this x value is here, if I go from here to the right, then the blue curve is always going to be below the red curve. It's not to the left-hand side. You can see that the blue curve is then above the red curve, but then from wherever this point down here is, from here left, then we can see again that the blue curve is always below the red curve. So we just need to figure out these critical points. This point here, I need to know where that is, and also where is this point, where is this amount here. So if we work that through, we can go on to menu, analyze graph, intersection, and then that will find out where these two things cross over each other. So I can see that they cross over when x is equal to 1 1/3 or 1.3 recurring. So when x is greater than 1.33, the blue curve is less than the red curve. 5 over 2x minus 1 is less than 3. The asymptote, I can see that there's an asymptote going down here, and that is actually at x is equal to 1/2. We'll look at how we could find that. If we go on to menu and then go on to table, we can do a split screen table, and we get all these different x values, and we can see what the corresponding y values are going to be. So what we can see is that when x is equal to 1, y is equal to 5. When x is equal to 0, y is equal to minus 5. So I know, therefore, that my asymptote must be between those two values. And actually, given the symmetries, we can see that it's going to be halfway between those two values. It's going to be at 1/2. But we could just find that exactly. We could say on our table that we're going to edit the table settings and that we want the step to be a little bit smaller than 1, because going up in 1s we couldn't actually capture exactly where that asymptote was. So if we go up in steps of 0.5 instead, now we can see that on this one here, where x is equal to 0.5, the graph is undefined. And whenever the graph is undefined, that's an indication that there's an asymptote in that position. Therefore, for x is less than 0.5, we are again going to have a situation when the blue curve is below the red curve. 5 over 2x minus 1 is less than 3. So that's the other part of our inequality. X is less than 0.5 or x is greater than 1.33.